What's going on, guys? This is Dean here. This is a tutorial on LangChain and how you can essentially use this framework to build very powerful applications on top of the language learning models that we love and use today. This helps solve a lot of the limitations that are associated with the language models, such as GPT-3 and GPT-4. But my kind of whole goal with this is to, to have you guys not only understand the concepts of how you can use a tool like this to create applications, but also provide you guys some very specific use cases to get your juices flowing. LangChain is essentially a tool, a framework that that's built, that's powered by language models that not only connects your language models to other sources of data, becoming more data aware, but also can interact with its environment a lot more. Be agentic is the term that they use. And I think the combination of these two is very, very, very powerful. There's a whole lot of use cases that come with this. And the whole kind of idea with LangChain is they're trying to essentially abstract all of this, make it very easier for developers like me who, don't have, too much of an understanding of very low-level concepts to just come in and create, again, powerful applications that are leveraged by these language models. And another thing to mention is that I'm actually actively working with a company local here to implement something like this into their current existing operation. And I think that's important to mention because it's one thing to, preach from a textbook, but it's another to actively work on a project, be involved deep in the trenches, understanding their current systems, their softwares they use, and essentially connect the dots together. And that's why, and that's kind of my whole goal with this video is, this technology is obviously available to all of us, but it's more so of what you can make of it, right? What, current industry are you in, and how can you essentially leverage your knowledge of this to connect the dots and create something that can be very valuable to a company, ultimately helping increase their revenue, which is the bottom line. So yeah, guys, let's get into this. Before we actually get into really what LangChain is, I would like to go over kind of some of the very current limitations of LLMs. So again, such as GPT-3 and GPT-4, and I've highlighted them here, and they do kind of all relate to one another, but they are not very scalable. It's difficult to tie actions to them. Pricing becomes a factor. You can't really build complex workflows, and it's hard to kind of interact with its environment. And again, these are going to make a lot more sense kind of as we get into it, but I would like to show you here, obviously say we wanted to use the annual reports that Apple provides its investors, right? So this is an 80-page document, and traditionally with it's the current language models out, they're only trained, first of all, up until about, I think, middle of 2021. But second of all, as far as from a, you can't even, you wouldn't even be able to use this data as, there's 80 PDF pages, and that goes above the token limit. So, we can just go ahead and test that right now. So if we were to essentially, copy, let's say, probably, I'd say 20 pages, just 20 pages out of the 80 that they provide us, and we come into the tokenizer, we can actually, paste it in, and you can already see, let me just refresh this, you can already see that we are above the 8,000 token limit. So we essentially wouldn't be able to even, use any of this data unless obviously we kind of split it up. But that kind of goes against the whole idea of this because, obviously then you would have to use only just certain paragraphs. But how do you know if you're not leaving other context out? There's a lot of manual intervention associated with this, so it just doesn't make sense. And that's kind of, again, one of the things that LangChain helps us resolve with the use of embeddings and semantic search. And OpenAI does this as well, again, but this idea of LangChain is just the abstraction. It makes it a whole lot easier for developers to build these very powerful applications. For example, let's say we wanted to develop a a lead generation application for a dealership, right? This could be a very big dealership, a local one down the street, whatever. Let's say we want to essentially develop a customer-facing chatbot. This is kind of how I see it. A customer would be able to come in and ask, hey, I'm looking for a car that's so-and-so. Is this something that you guys have in your inventory? And it would essentially give that response and also maybe even schedule an appointment, right? So again, I'm going to try and make this as simple as possible, but obviously traditionally, if we wanted to do this with the current models, A, it wouldn't even have access to this company sensitive information, such as their inventory. And B, this would be a lot of data, especially if we had the inventory of a bigger dealership, and give it more details about the description and whatnot. So yeah, guys, essentially this is the workflow that would be provided with, this is how I would do it with LangChain. So essentially, I kind of provided the use case of it. So let's say in order to do that, we would first need to provide it a inventory, Excel or a CSV spreadsheet of the of the products that they house, that the dealership houses. So again, this would be way too big of a PDF to just load into GPT. So what we would need to do is first we would convert this into a readable text using some of the document loaders. And then from this text, we would essentially chunk it into different paragraphs, if you will, or just different sections. So for example, let's say this inventory CSV, it has everything, all of the models, all of the descriptions, the price of all the different cars. And we would essentially kind of split those, that inventory into different chunks. And, for example, one of the chunks could be mid-size sedans. One of them could be trucks. One of them could be sports cars. To be honest, it doesn't really matter. All that matters, really, the concept I'm trying to get around is we're just essentially splitting this very big CSV file into separate chunks. And then from there, we essentially convert them into embeddings, and then we store them in a vector store. So you can just think of this as a database, right? So I'm going to explain the concept of embeddings, of how vectors work really quick here, but just know that we're essentially taking each one of these chunks, converting them into a vector like this one shown here, and then storing them in a database. And now you're probably wondering, what the hell is this, this vector here? What is a vector? And a vector, this essentially allows our computer to understand, to understand what are these chunks exactly, right? Because to the computer, it's just a ton of words. It doesn't have any understanding of what these, what the vehicle models are, what the descriptions are, what the, what the prices are. But essentially, it converts them into a one-dimensional array called a vector. And from this vector, it's going to be able to compare it to what the user asks and provide the relevant data that's needed. So again, this will make a lot more sense here. I have a kind of simple concept of a two-dimensional relationship between these, between a sedan, a truck, and an airplane. I saw a lot of useful illustrations like this online. I thought I would make something similar. So you can see that with the kind of three items that we have mapped here, a sedan and a truck and an airplane, you can see that a sedan and a truck are more similar to one another than an airplane that's down here. They're all three vehicles that can be man-powered and use petroleum. But a normal keyword search wouldn't be able to distinguish the difference between a sedan and a truck because it would say a normal keyword search, like a basic keyword search, it would just look for the characters that are in this word and compare them. And you can obviously see between a sedan and a truck, there's no keywords that or phrases that are similar between the two. So technically, a computer wouldn't even know the difference. That's why we convert it to a vector, and then we essentially use something called a cosine similarity. And essentially, you can see here it's like the angle. You can see it's shorter between the sedan and the truck. That means they're a lot more similar. Now, this is just a two-dimensional relationship, right? We have an x and y axis. Now, with OpenAI's embeddings, there's actually 1,536 different dimensions, which is just mind-boggling to me. So, again, if you don't fully understand this yet, it will make a lot more sense. But essentially, just understand that this semantic search that we did is a lot more relevant, a lot more foolproof than, say, something like a basic keyword search, because then a computer wouldn't really know what the difference is between these three. But obviously, since we've converted it to a vector, it can these numbers, it essentially knows the difference between the two. So again, this will make a lot more sense as we go through this. So essentially, once these vectors are stored in this database, all of the vectors of each of these chunks. So each one of these chunks is going to have different vectors associated with it. And again, these chunks are from the big inventory CSV that we gave it. So now, let's say a user asks a question. Which cars do you have in stock for a sedan that's great for the family, great MPG rating, and it's a newer model? So it would take this user input here, and it would create an embedding, just like we did with the chunks, right? Just like we did with the company data, and it would create an embedding for this, search, this user input. Now, it would use that similarity search between these two, embeddings, these two vectors, and it would find, now the computer would essentially know, okay, out of that big spreadsheet that we gave it, and what the user asks, only use the relevant chunks that are associated with what the user asks. And this is how the computer understands it. So it just essentially compares these two embeddings using similarity search, which is just the cosine similarity. Again, you don't really need to understand that, but I thought it'd be important concept to learn. So from that input, it would only grab the two relevant chunks that are essentially associated with what the user input is. Now, it would create a new prompt. So it would say, which cars do you have in stock for a sedan that's great for family, great MPG rating, and then it would grab the two chunks that it pulled out that are most similar to what the user inputted. So for instance, it would grab these records from the CSV, Honda Accord, Toyota Camry, and the Sonata. And along with this, whatever records are associated with that vehicle, such as the description, price, etc. But now, I hope that this kind of concept is making a little bit more sense. Out of that big CSV that we handed it, it's only grabbing the just relevant chunks, using this similarity search with the embeddings. So now, this is essentially the prompt that we're going to plug in now to the large language model. So again, this is technically, you could just go into ChatGPT and do this, but again, this whole this is a lot more systemized, and again, now you can see how much more cost effective it is than, say, plugging in something like this, or even if it's below the 8,000 token limit, it would still be a lot more expensive if you're doing this at scale. So then, again, with this new prompt provided, it gives us an answer. So it'd say, hey, customer name. So, hey, Jack, we currently have these vehicles in stock at our location that might interest you. It would give you the relevant cars, and then maybe you would ask something like, would you like to schedule an appointment to come check it out, right? So this is kind of the use of agents. Again, LangChain, we're just touching the surface of this. There's a whole lot you can do, which I'm still learning as well, and it's completely mind-boggling to me. But this is essentially how we would develop a solution like this at scale that's also cost-effective. So again, kind of going past the current limitations of large language models. So I hope this kind of whole process makes sense. And again, this is just kind of one of the tools that are associated, or one of the components that are associated with LangChain. So you can see there's a whole lot more. And again, guys, I really recommend you guys check out their documentation. Just read through it. Even if you're not a developer, I think it's still important just to learn this technology and, again, just kind of get your juices flowing of what's possible and what's not, right? And a whole lot is. So we can see the different components. And again, I'm not going to get into each of them, but it's important to understand all of them. And essentially from these different components, you can essentially create a more complex chain I mentioned. So a more complex workflow, for example, that we'll get into. And then there's also agents, which that this is going to be the next example I provide, but essentially they can make decisions of what actions to take on behalf of the user or the language model. So it's pretty nuts how it does this. It kind of has its own like logic and reasoning associated with it. But again, to better kind of understand this, I want to provide another use case, and we'll just stick with the dealership example here. But essentially, as you guys saw here, an agent essentially allows us to communicate with our external environment, take actions. It involves some decision making, and so an agent would essentially have a toolkit. And with a dealership example, you can see, for instance, these may be some of the tools that are the agent has access to. So say the service records of a dealership, or the in-house CRM that the dealership uses, or the company email integration, right? Whatever company or whatever email software they use to send out automated emails to customers, potential customers, or for a service appointment, which we'll actually look into here. So again, this would be a kind of more complex chain, but this is something that's definitely possible with LangChain. And this is kind of how a customer service or a customer agent interaction would go. So, and again, I hope this makes a lot more sense as I go through this. So for example, the customer would say, hey, I bought a Jeep with you guys and I think my brakes are very squeaky. The service representative, this is the bot, would say, hey there, do you have an email address, phone, or vehicle VIN that was associated with your vehicle? And then essentially it's just trying to collect data. And we would say, yes, my email is, provided here. We would essentially extract that data, and then the bot would have access to the, to not only the service records, but also, let me add that here, but also their in-house CRM. So we can see here, we're saying, hey, Dean, pleasure to hear from you again. Please give me a second while I quickly look into this. So now the service representative, the large language model has access via the tools, via the agent, to access the company's service records as well as their in-house CRM. So you can now see in our next response, we're saying, hey, Dean, when you purchased your car, it looks like the brake pads were almost out, because it probably got this data from the, the service records, right? It looks like you need replacement pads. Since you purchased your car less than 60 days ago, we'll go ahead and give you free replacement brakes. When are you available to come in and schedule an appointment? And I know this sounds completely wild. Like, how the hell would it be able to, come up with this reasoning and this logic to do all this? But I assure you, it is possible. But yeah, essentially, it would have access to this external information, and it could take actions on behalf of the model. So it would know, for example, that you bought your car less than 60 days ago because it had access to the company's in-house CRM. And then because you bought it less than 60 days ago, it's going to offer you a free replacement brakes because that's, for example, the company policy, right? This is data that you would train it. Or not train it, this is data that you would load in to the language model. And then it also asks you to schedule an appointment. So again, we can see here in the next response, the customer would say, oh man, thanks for letting me know. I'm free this Thursday if that's available. So from that response I gave it, it would look again in the CRM or in the service records and see, okay, this Thursday we have spots available for 10:30. So you can see our bot here. It schedules it for 10:30 a.m. this upcoming Thursday. And it even sends, for example, an email confirmation out to the customer to confirm the appointment. So again, that's just another tool that it has access to, the email integration, and it would essentially send out a tool, a service appointment confirmation, giving a little bit more details about what they're coming in, when, and a confirmation for the customer to confirm. So again, guys, all of this is possible. Now I hope by now you kind of understand a little bit more of what's possible and how powerful a abstraction framework like LangChain is. And again, this is just kind of on the top of my head I was developing, but something like this is possible. And not only does this, and guys, there's so many benefits associated with this for a company. Because, for example, let's say there's two dealerships, right? One down the street and another one a few miles out. And I would, me being obviously kind of, and you guys too, watching this, tech savvy people, you would most likely go with the dealership that has an integration like this, integrated into their current system, because it's just so easy, right? Because not only do you not even need to talk with a service representative, but you could essentially do this at whatever time you need to, even when the agents aren't working. And not only that, it's just so much more of a streamlined process. Just from the email, for example, the language model would be able to not only grab this information, but also have its own logic and reasoning. And like I said, kind of with all the association with all of these tools, the fact that it can do something like this is nuts to me. And not only will this save the company a lot of money, but also it can streamline the process. It can, for example, generate leads for the service records, or for the service department of a dealership during off business hours. And customers would probably feel a lot more comfortable knowing that, hey, this dealership can, for example, look up all of that specific information just from something like an email. Or maybe, if you didn't shop there, for example, you'd have to provide its VIN number, so it can, look up this information in like a nationwide database, if you will. So yeah, guys, this is, again, this is just one of the use cases that I thought of. But again, all of this is possible with LangChain, and I really recommend you guys check out their documentation. Just learn a little bit more about how everything is, how all of the kind of components come into play, how to make more complex chains, different prompt selectors. It gets pretty, I wouldn't say complex, but it really frees up. The abstraction really just allows you to build really whatever for your company, whether this is something internal to your team, or or something that's more customer facing. So yeah, guys, I hope you learned something from this. Let me know if you guys want more like high level videos like this with concepts, other use cases, or you want more kind of technical videos of me actually coding something, coding an application with LangChain and, GPT-4 or 3, for example. We could maybe do like a video series on this or whatnot. But my time is going to be pretty strapped up, as, again, like I said, I'm actually implementing this into a business local to me, into their current systems and operations. And although I can't share too much information about that, I would like to kind of, maybe document my journey, and what I've learned, implementing this. So yeah, guys. And along with this, we are actually creating a kind of a no-code. And I say we, my friend and I, we're actually creating a no-code software that can implement, with a tool such as bubble.io and Webflow. So you can, for example, import company specific data, whether it's SOPs, just information related to products, whatever it may be. You can essentially implement that and integrate that into a no-code tool. Almost abstracting it even more. But yeah, guys, if you guys are interested in this, just let me know kind of what style of videos you want, or maybe you kind of like this more high-level overview of this. That's perfect fine. I really enjoy doing this. I did just create a new Discord. If you guys are interested in chatting with other developers that are building applications that leverage AI, be sure to join the Discord down below. I'll also be a lot more active in there to help answer any questions you guys may have. But yeah, I hope you guys enjoyed this, and I will see you in the next one.